Welcome back to the deep dive. Today, we're on a pretty critical mission. We're going to move beyond just building, beautiful static
It's
websites.
the digital equivalent of a painted wall.
Exactly. We're diving deep into building websites that actually do things. We're talking about projects that can listen, that can remember, and that respond. Essentially, we're building the digital heartbeat of a real application.
That's a great way to put it. Our listener is really looking for the blueprint for modern web apps. They want to get past just the design layer and understand the plumbing.
The plumbing.
Yeah, the connections, the wires,
Right.
the language that lets the front end talk to the back end. And the source material we're using today is just this incredibly practical guide for building these systems with modern, often free, and even AI-accelerated tools.
It sounds like a shortcut, almost.
It really is. It's a shortcut to fluency in this whole full-stack world.
And there's a quote from the source that I think just frames this whole discussion perfectly. It says, "The front end greets the world, the back end remembers it. Integration helps them talk."
And it all comes down to that last part. That
Yeah.
communication has to be robust, it has to be secure, and, it has to be fast.
So by the end of this deep dive, what's the goal? What will you walk away with?
Okay, so the goal is to completely demystify that communication. You'll get a rock-solid grasp of what full-stack development really means today. You'll understand the role of the API, that's the bridge we'll be talking about, and maybe most importantly, you'll see real, tangible ways to use AI and tools like Netlify, Vercel, and Supabase to make this whole process simpler.
And actually get a real functioning app out there.
Exactly.
Yeah.
Deployed and launched.
Okay, so let's start with the big term here, full stack. It used to sound, it sounded like you needed 3 different degrees to even attempt it.
Right. It was very intimidating.
But now, with modern tools, it feels a lot more achievable. So what does full stack actually mean today?
Fundamentally, it's about combining two worlds. Everything that happens on the screen, the entire user experience, with everything that happens behind the screen.
Storage, the logic.
The storage, the logic, the security.
Yeah.
The source material breaks it down into really clear components.
So the front end, that's what we can actually see.
Yes. That's your HTML, which is the structure,
Mm-hmm.
your CSS for all the styling, and then your JavaScript for the interactivity. That's all what we call client-side code.
Meaning it runs in my browser.
It runs entirely in the user's browser. Its job is to gather input from the user, display results, and just make everything look and feel seamless.
And then there's the back end.
And that's the brain and the memory. It's made up of the server, which is the environment where your logic runs, and the database, which is where all the important information lives permanently.
And that's not on my machine, that's somewhere else.
Right, that's on a remote machine, just waiting for instructions from the front end.
I really like the metaphor the source material uses here. It says a full stack creator builds both the house and the plumbing. It's just a really easy way to picture it.
It's perfect because it shows how dependent they are on each other. The house, the front end, it can be gorgeous. Beautiful design, perfectly responsive.
But if there's no plumbing?
If you haven't wired up a server or a database, you have a building that can't do anything useful. You can't save a new user's registration. You can't look up an old order. The taps don't work.
That makes me wonder, though. Browsers are so powerful now. Why can't a website just save the data locally on my machine? Why do we always need that back-end plumbing?
That's a fantastic point, and it really gets to the core of it, the difference between, say, utility and longevity. You can save some things locally in the browser, sure.
But it's not permanent.
It's transient. If the user clears their cache or switches to their phone, or if you need to use that data across thousands of people, it has to be centralized. The back end gives you persistence, security, and scalability. It's the central control tower for your app's logic.
So if a website looks amazing but can't save a single message from a contact form, it's not really alive.
Exactly. The source calls that a body without a heartbeat. Integration is what connects the visuals on the front end to the memory on the back end.
Yeah.
It's what gives the project life.
And the key takeaway from that?
The takeaway for anyone starting out is this. Every single click, every form field you fill out on the front end has to be translated into a clear instruction that the back end can understand and act on. Without that, the whole thing is just inert.
It makes it feel less like pure coding and more like, communication management.
It is,
Yeah.
which is why the coach's insight in the source is so good. It says integration is about connection, not complexity.
I like that.
It's about making sure the wires are hooked up safely and are both speaking the same language. And that standard language, that protocol for connection, is managed by the API.
Okay, so let's cross that bridge. The API, Application Programming Interface. We hear this term all the time, but for a lot of people, it's the missing link. What does it actually do? Why do we need it? Why can't the front end just talk straight to the database?
The API is essentially a digital contract. It's the safe, predictable, and standardized messenger between the front end and the back end. Think of the database as a vault full of valuable data and the server as the guard.
Okay.
The API is the only window where you can ask the guard to place or retrieve very specific items from that vault.
And why the window? Why not just go straight to the vault?
Security and structure, primarily security. If your front end could talk directly to the database, you'd have to put your database password, the keys to the vault, right there in the public code.
Oh, wow.
It's
Right.
total security suicide. But beyond that, the API is also this critical validation layer. It makes sure the request is formatted correctly, that the user is allowed to make it, and that the data being sent follows the rules before it gets saved. It's a bouncer.
So it's the waiter, the bouncer, and the translator all in one.
Exactly. It's the API bridge linking the front and back end securely. And the real-world examples in the source make this really clear.
Let's go through them. The weather app.
Right. So the front end, your phone, doesn't ask for all the raw weather data in the country. It just makes a simple request to the API. Please give me the current temperature for this location.
And the API replies.
With a clean, simple piece of information, 32 degrees Celsius. Structured query, structured response.
Makes sense. What about the contact form?
Same idea. The front end bundles up the name and the message into a little data packet. It sends it to the API and says, here's a new message, please save it. The API checks the fields, saves it to the database, and then sends back a simple success message.
And the high-stakes one, the payment gateway.
Right. When you click Buy, the front end does not handle your credit card number. It can't. It sends a request to the payment API saying, process this secure token for $50. The API does all the secure talking to the bank and just confirms if it worked or not.
Okay, this brings us to the AI assist. If an API is just code following these predictable rules, how is AI making it easier to create them?
Because historically, creating these API endpoints involved a lot of boilerplate code. It's repetitive, it's easy to make a typo, and AI is just brilliant at this stuff. You can use something like GitHub Copilot or ChatGPT and just generate the basic structure instantly.
The source is that great example prompt.
It does. Write a simple API that receives a user's name and returns a greeting.
So the AI is just doing the grunt work of the syntax and the setup. The source shows a little JavaScript snippet from a framework like Express.
Yeah, Express for Node.js is kind of the classic for this. It's light, it's fast, and AI models have seen millions of examples of it. So the code it generates is small but perfectly functional, something like app.post. Hello, Rick Rex.
Let's break that snippet down because that little block of code has the entire concept of integration packed inside it.
It really does. So first you have app.post hello. That's defining the specific address, the endpoint, as hello. And crucially, it specifies the method is post.
Which means I'm sending you data.
Exactly. I am expecting to receive data. Then you have rec.body.name. The rec is the incoming request, and the user's name is inside the body of that request. The API is just pulling it out.
And the last part is the response.
Right. res.send. Hi, name, welcome. That's the server, the res, generating a custom response and sending it back.
So in a few lines of code, which AI can write in seconds, you've connected what a visitor typed on the front end to a completely dynamic response from the back end. That's a full communication loop right there.
And that loop, that whole system, operates on a constant three-step rhythm. We call it the request-response cycle. If you get this loop, you get the basic architecture of almost every interaction on the web.
Okay, let's lay out those 3 steps again, but let's talk about what happens when each one goes wrong.
Perfect. So step 1 is the request. This starts from the client, from your browser. It's asking for something.
Right.
A GETty request to see a page or a POC request to send some data.
And if that request fails right away?
If it can't find the address it's looking for, you get a 404 error, not found. The server's basically saying, I have no idea what you're asking for at this address.
Got it. Step 2 is process.
The server receives the request. This is the API and the back-end logic doing the work. It checks who you are, it validates the data, it stores the message, it runs the calculation, whatever the instruction was.
And this is where the server itself can break.
Yes. If the processing fails, maybe the database is down or your code has a bug, the server will send back a 500 error, an internal server error, A 500 tells you, I got your request, I found the address, but I broke down while trying to do what you asked.
Knowing the difference between a 404 and a 500 is huge for debugging.
It's foundational. One is a wrong address, the other is a failure at the destination.
And finally, step 3, the response.
The server, having done its job, replies. It sends something back to the browser. That could be the data you asked for, like a list of blog posts, or just a status code like 200 OK, or a message saying thank you, and that response updates the front end.
What's so useful about this is that understanding this rhythm gives you like an X-ray view into your application when it's broken.
Absolutely. You can open the developer tools in your browser, go to the Network tab, and literally watch this happen. You can see your request leave, see what status code came back, and check if the data packet you sent was even formatted correctly. It turns an abstract idea into a real diagnostic skill.
Okay, let's move from that abstract loop to some actual tangible steps. We're going to conceptually build that first full-stack link, a simple HTML form connected to a database.
Right, this is all about bridging that language gap between what the browser knows and what the server needs.
So step 1 is the front end, the HTML.
This is purely for collection. You have your HTML form tag, your input fields. It looks nice, it accepts text, but it doesn't do any connecting on its own. The key part here is using JavaScript to stop the form from submitting in the old-fashioned way, which reloads the whole page.
And step 2 is the backend, the API logic.
So that's the code running on a serverless function somewhere. As we saw, its job is clearly defined. Received data from the request body, call a function to save it to the database, and then send a success response back.
Okay, now for the most important part. Step 3, the connection. This is the JavaScript on the front end that actually does the sending.
This is where we need to get into the weeds a bit. This JavaScript code stops the default form action, it collects the user's input, and then it formats it. It creates a JavaScript object, like name, Alice.
And then it uses the fetch command. What does fetch need to actually talk to the API successfully?
Okay, so fetch is the browser's command to send data. For a POS tree request, it needs 3 essential things.
1.
The endpoint URL, telling it where to go, something like contact.
Okay.
The method. You have to explicitly set it to POST. You're telling the server you're sending new data, not just asking for it.
And 3, the body and headers. This is the tricky part.
This is the part everyone gets wrong at first. You can't just send a raw JavaScript object over the internet. The internet mostly speaks text, so you have to use JSON.stringify data to convert your object into a perfectly formatted text string.
So the JSON string is like the sealed envelope with the data inside?
Exactly. But you have to label the envelope correctly, too. That's the headers. You have to include the content type header and set it to application JSON.
And what does that do?
That header is a little label on the packet that says, Dear server, just so you know, the text inside this envelope is formatted as JSON. Without that, the server gets the data but has no idea how to read it. It's like getting a letter in a language you don't speak. It often just fails silently.
Wow. So that one little header is the difference between working code and robust integrated code.
It really is.
Yeah.
It's the polite handshake that ensures the server understands the request. And the payoff for getting those 3 things right, the post method, the JSON body, and the header, is a website that can instantly receive and store messages. It becomes a living system.
Okay, so building this requires a whole team of tools working together. Let's talk about the deployment landscape. Where does all this code actually live and run?
The modern way to do this is often called Jamstack, or serverless. You break the old single server into specialized services. And the free tiers on their platforms are just incredibly generous.
Let's start with hosting and deployment. What are the big names?
Vercel and Netlify are the leaders. They handle all the complicated infrastructure stuff for you. You can deploy your front-end code and your back-end serverless functions together seamlessly.
Any difference between them?
Vercel is highly optimized for React and Next.js, and its focus on serverless functions makes it a great choice for JavaScript-heavy apps. Netlify is also fantastic, and it's especially good for static sites that need some dynamic features added on top. Super flexible.
What if I just need a tiny bit of server-side logic, like for one form?
That's the whole point of serverless functions.
Yeah.
Instead of paying for a server to run 24/7, you just write these small scripts that only run when they're triggered.
And the source highlights a couple of options for that.
Yeah. Firebase functions are great, especially if you're already in the Google ecosystem. And then there are Supabase edge functions.
What's special about those?
This is where integration gets really smart. Supabase edge functions are designed to run physically closer to your database. That closeness dramatically cuts down on latency, so your data storage and retrieval feels almost instant. And it comes pre-integrated with secure database access, which simplifies things a lot.
So these serverless tools basically handle the process step of our cycle, but without us having to manage actual servers.
Exactly. They handle the scaling, the security updates, all of it. The other tools mentioned, like Firebase hosting and Replit deploy, are also great for getting started and for quick prototypes.
And let's not forget that coach's tip. Always test the site on a phone before you share the link.
Oh, absolutely. If your integration works on your big desktop monitor, but the form breaks on a small screen because of a layout issue, you've lost that user. You have to test in real-world conditions.
Okay, so we've talked about writing code to build these API bridges, but now we're getting into a whole other world, integration without code, using automation tools like Make and Zapier.
This is just transformative,
Uh-huh.
especially for non-developers or for connecting services that you don't own. These platforms are like an AI intermediary that handles all the API translations for you behind the scenes.
So the idea is you create a chain of events. A trigger in one app causes an action in another.
Precisely. It's all based on a logic of triggers and actions. You define the flow with a visual drag-and-drop interface, and the platform handles all the messy API calls, the authentication, the error handling, all of it automatically.
Let's walk through that multi-step workflow example from the source, something like an event registration system.
Okay, so the journey starts with a trigger. A user fills out a simple Google form. The automation tool, let's say it's Make, is just sitting there watching that form for new submissions.
Then Make jumps in.
Yep. As soon as a new form is submitted,
Mhm.
Make grabs that data.
And the first action is to store it.
Right. Make takes the name and email and adds them as a new row in a structured database, maybe Airtable. It handles converting the data from the Google format to the Airtable format.
Okay, and then the second action, communication.
So right after it saves the data, Make can then take that email address it just received, connect to your Gmail account, and send a personalized welcome email confirming the registration.
That's just staggering. You have 3 totally separate services, Google, Airtable, and Gmail, all working together from a single user action, and you didn't have to write a single line of API code.
The applications for this are just immense. This is how people power their newsletters, manage support tickets, update inventory when an order comes in. It proves that sometimes being a great integrator means knowing how to connect existing tools, not building everything from scratch.
Let's make this even more real with the case study from the source. The story of Hamza, the 17-year-old organizing cleanups. He didn't have a big budget or a dev team, but he got serious results.
Hamza's story is the perfect example of using these tools for real impact. He just needed a simple system to register volunteers for his neighborhood cleanup campaigns and communicate with them.
So what was his stack? What tools did he integrate?
It was simple, accessible, and really powerful. For his front end, he used a tool called Software, which lets you build simple apps on top of existing data.
And his database.
That was Airtable. It was the central memory for all the volunteer names, their contact info, and so on. And the engine connecting them all, the automation, was Make.
Okay, so let's trace the journey of a volunteer through that system.
So a volunteer goes to Hamza's site, built on Software, and they fill out the sign-up form. That form immediately pushed the data into his Airtable database.
And Make was just watching that database?
It was watching that table. As soon as a new volunteer's name appeared, Make's trigger fired. And its action was to automatically send a personalized confirmation email and add them to the official event list.
So Hamza didn't have to do any of that manually.
None of it. It saved him hours and hours of tedious admin work. And the result was 25 signups in the first week. It just shows that efficiency really drives participation.
It goes back to that coach's tip. Real impact happens when code serves a cause. He let the system handle the logistics so he could focus on the actual organizing.
That is the power of integration. It turns a simple idea into a functional, scalable system.
Okay, now let's talk about the elephant in the room. When you connect all these different systems, things are going to break.
They will. Guaranteed.
The more pieces you have, the more places for failure. The source calls AI the most patient debugging partner. Why is that so important when you're trying to fix these integrations?
Because the biggest headaches in integration are usually caused by tiny, almost invisible errors.
Yeah.
A typo in a URL, a missing comma in your JSON, a wrong security setting. As a human, you can stare at it for an hour and not see it. An AI doesn't have that problem.
So I can just give it my code and say, my API isn't getting any data from my front end, and I'm seeing a 403 error.
Exactly. And the AI can instantly review your code and spot something common, like a missing CORS header, and tell you how to fix it.
We mentioned CORS before, but let's define it clearly, because this is probably the #1 integration headache for people starting out.
It is. CORS stands for Cross-Origin Resource Sharing. It's a security feature built into all browsers. If your front end is hosted on one domain, say my-app.com, and your API is on another, like api.backend.com, the browser will block them from talking to each other by default.
It's a security measure.
That's like a border guard saying, "Whoa, this request is coming from a different country. Are you sure that's allowed?" The backend has to explicitly give permission by setting the right CORS headers. If it doesn't, the browser blocks the request and you get an error.
And AI is good at spotting that because it's such a common problem.
It's seen it a million times. It knows to check your server's security permission slip first.
The source has a great troubleshooting table. Let's run through it. If the symptom is, my form sends data, but I get a weird error or just no response at all, what's the likely cause?
Most likely cause is a wrong API path. You just have a typo in the URL. Your front-end fetch is trying to send data to contact, but your API endpoint is actually defined as submission. You have to check it character by character.
Okay, what about a page that loads, but it's really slow?
That's usually too many scripts or just unoptimized code on the front end. It's not really an integration failure, but it kills the user experience. You can actually feed your code files to an AI and ask it to minify or bundle them to make them smaller and faster.
And that really tricky one we talked about. I submit the form, I get a nice thank you message back, but my database is totally empty.
The silent failure.
Yeah.
That almost always points to missing PSOS method.
Huh.
If your front end accidentally uses the default GateT method, the server might process the request because the address exists, so it sends back a 200 OK.
But it ignores the data.
It completely ignores the data payload because it wasn't expecting one. The data packet just gets dropped on the floor, so you have to double check that method. Post in your fetch command.
So integration gives the system life, but that life has to be protected. If you're handling any kind of personal data, security is not optional. What are the golden rules for secure connections?
The source outlines 4 security rules that you absolutely have to build in from day one.
Rule 1.
Always use HTTPS for all your endpoints. This encrypts the data as it travels between the browser and your server. If you don't, the data is sent in plain text. Anyone on the same public Wi-Fi could potentially read it.
And browsers will flag your site as not secure now, too.
They'll actively penalize you for it, so it's not even a choice anymore.
Rule 2 is about those secret keys.
You must hide sensitive API keys using environment variables. These keys for your database, your payment processor, your email service, they are the master passwords to your infrastructure. You can never, ever put them in your front-end code where they can be seen.
So how do environment variables actually hide them?
They hide them by making sure the key never even reaches the browser. The variable is a setting stored only on the server where your API is hosted. When your back-end code runs, the server injects the secret key at that moment. It never leaves the server's memory.
Got it. Rule 3, never trust the user.
You have to validate user inputs. The API's job is to protect the database. If you're expecting an email, you have to check that it's actually in an email format. If you're expecting a message, you have to make sure it doesn't contain malicious code that could attack your system.
And AI can help write those validation checks.
AI is great at writing the complex little patterns, the regular expressions, to validate things quickly and correctly.
And the final rule is about protecting the database itself.
Never expose your database URL publicly. This connection string is the key to the entire vault. It should only ever be accessed from your secure server-side code using those environment variables we just talked about.
And just like with debugging, we can use AI to be proactive about security.
That's the modern advantage. You could do AI vulnerability scanning. You can literally paste your API code and ask, check this for security risks, or does this code protect against SQL injection? The AI can spot weak points before a hacker does.
Okay, we've covered the theory, the tools, the troubleshooting. For the listener who is ready to go from concept to actually building something, what are 3 practical integration ideas from the source that they can try?
These are designed to make you use the full request response cycle, the Fetch API, and one of those free platforms we talked about.
Idea number 1, the basic one.
A blog comment system. This is the perfect starter project. You build an HTML form. The challenge is to link that front end to a free database like Supabase. You have to successfully use a POST request to send the comment text into permanent storage. It's a pure test of your data transport skills.
Okay, idea number 2 gets a little more complex. It involves some server-side logic.
The online quiz. So the front end shows the questions and collects the user's answers. But here's the trick. The correct answers can't be in the front end code or people will just cheat.
Ah, right.
You have to send the user's answers to an API, where the secret scoring logic lives. The API calculates the score and then sends just the result back. And if you want to go a step further, the API can then save that score to a database.
And the most complex idea, which involves multiple services.
The donation tracker. This is a real-world system. The front end collects the donor's information. Then you have to connect to an external payment gateway API like Stripe. Your app sends the payment info to Stripe. Stripe sends you back a success confirmation. And only then does your own server logic record the successful transaction in something like a Google Sheet or Airtable.
So that's a three-way integration, your app to Stripe and then to Google Sheets.
Exactly. It's a great test of managing a multi-step asynchronous process.
This has been an incredibly detailed look at how to stop building static walls and start building living applications. Let's just quickly recap the key lessons.
We covered the absolute essentials. Full stack is that necessary connection between the front end you see and the back end you don't. The API is a secure bridge for their communication, and it demands proper structure, like using the POSD method and the right headers.
And we saw how automation tools like Make and Zapier can act as these AI go-betweens, connecting services without you having to write any code. And of course, security, HTTPS, hiding your keys, that's what makes a project professional, not just a demo.
And we really hammered home that modern development is just accelerated by AI tools and all these generous free services from Vercel, Netlify, Supabase. These are the building blocks that make full-stack development achievable for everyone now.
And I love that final insight from the source. A full-stack creator doesn't know everything, they connect everything. It's curiosity, that drive to figure out how two systems can talk to each other. That's the real skill.
Absolutely. Integration is what turns an idea into a system, a project that can listen, think, and respond. The next step, as the source suggests, is taking these integrated systems and just polishing them, testing the speed and reliability of those connections so they work perfectly on every device.
So after absorbing all of this about these incredible accessible tools and the security steps and automation platforms that are free to start using, we want to leave you with one final thought to explore on your own.
Think about the combined power of these tools we discussed: Vercel for hosting, Make for automation, Supabase for your database. Given that these essential services exist and that they're so easy to connect, what previously impossible or just really difficult multi-step idea can you now prototype and launch by simply connecting these free services together? What system can you build that truly lives, remembers, and responds?